Hi, this is Sean Gupta. This tutorial is going to be a short, roughly 1 hour long introduction to machine learning. We're going to talk about what machine learning is, what it's used for, and what commonly used methods in machine learning are. Let's get started. So we're first going to talk about what machine learning actually is, and then we're going to talk about two very well-known models. First, linear regression, and secondly, logistic regression, which despite its name is actually a classification algorithm. Then we're going to go on to model validation, which is a way of finding out whether the model that you fit is a good one or not so good one. Moving on, we'll talk about overfitting and underfitting, two common issues that you want to avoid when you fit your model. And then in number 6, we're going to talk about a general machine learning pipeline. So your model that you fit doesn't exist in isolation, but we're going to look at how does it integrate with the data that you have. Moving on, we're going to talk about tree-based models, namely decision trees and random forests, which also should be fairly easy to understand. And finally, we're going to put everything into perspective and discuss how we can combine and compare different kinds of models. Okay, so what is machine learning? Real-world data is very big and very messy, and it's very difficult for humans to find out what's going on in the data. This is what we use machines or computers for. Computers can find patterns and insights in this data automatically, and this is much easier for them, and hence machine learning comes in. Now, why do we want to find patterns? Well, we want to be able to predict events that would be difficult for humans to predict because humans can't look at all the data at once, and they're also not very good at finding the patterns. This is the basic idea behind machine learning. There are 3 broad areas of machine learning. First, there's supervised learning. Secondly, unsupervised learning. Thirdly, reinforcement learning. Let's start by talking a little bit about supervised learning. In supervised learning, you have a number of features or input variables. Let's call them x1 to xm, which essentially means you have m numbers or m features, and you want to use them to predict an output y, another number, or a class, something, anything that you want to predict, essentially. So what you want to do is you want to learn a function y approximately equal to f of x1 to xm. This means that if I tell you x1 to xm and you plug them into this function f, you can get an estimate of what y is. You won't be able to hit y exactly because it's a model and every model is approximate, but you will get close enough, and hence we have this approximately equal sign here. Next, there's unsupervised learning. In unsupervised learning, you don't want to predict anything. Instead, you want to discover structure that exists in data. For example, your business might have different customers and you want to segment them into different types in order to channel your marketing in a better way. Finally, there's reinforcement learning, and reinforcement learning is perhaps the most exciting area of machine learning. In reinforcement learning, you want to learn how to behave in an environment that you don't know in order to maximize some reward and to achieve some kind of goal. For example, a robot that plays football. This robot doesn't know where exactly the football is located. It doesn't exactly know where the other players is located. And it doesn't quite know how it should operate, like where it should kick the ball in order to achieve its goal, namely scoring a goal.